All right, we are now getting closer and closer to all of the fun and goodness that we're going to use with trigonometry. So, trig functions as points and finding angles that go with that. So let theta be an angle in a standard form. The point of x, y be a point on the terminal side of theta. The distance from P to the origin R can be found using the formula x squared plus y squared equals the radius squared. Hey, it's the Pythagorean theorem, except for like in a circle. Yeah, okay. So if that's the case, let's see. The sine is going to be this. It's going to be the opposite over the hypotenuse, which is y over r. Okay, now we're always going to read this off of the x-axis. So we're going to take the reference angle to do this, okay? So that's why it's y opposite over hypotenuse. Okay, how about if we want to do cosine? So that's adjacent over hypotenuse, x over r. The tangent, opposite over adjacent, y over x. Okay, then to do cosecant, we just like flip things over, right? So cosecant is sine reciprocaled, so r over y. Secant is cosine reciprocaled, so r over x. Cotangent, x over y. Okay, so these ratios and just understanding like why they happened, so valuable. And the more you understand this why, like how did this happen, the easier the trigonometry as we go into something called the unit circle is going to be. Okay, but right now, let's see, this one says p of 5, negative 2. All right, so we're going to have to put 5, negative 2 on here because this is going to give us some sine things. So 5, 1, 2, 3, 4, 5, negative 2, 1, 2. That's right here. Now, I'm going to draw a line, therefore, from start at the origin and go right there. So that's not exactly perfect, but right about there. Okay, so if this is the case, I now know some things, and I'm going to label those things. I know that this is negative 2. Super important that you have that at negative 2, and this is 5. All right, so find the exact values of all the things. Okay, but I don't know the hypotenuse yet. So I'm going to go a squared plus b squared equals c squared. Or the radius squared, maybe we should call that radius squared. Okay, so 4 plus 25. So 29 equals my radius squared, so square root of 29. Okay. Yes, that's yucky. It's always going to be yucky. Almost always. Okay, so now sine pi is going to be, let's see, opposite negative 2 over square root of 29. But remember how the square root of 29 can't be on the bottom? So I'm going to square root of 29, square root of 29. So I get negative 2 square root of 29 over 29. And you're like, that is so gross. And the answer is, yes, it's so gross. But we don't really care about we care about the concepts and the how you're doing it. So make sure, did I put a negative on there? I did. We just can't see it very well. The sign is super important. Okay. Let's see. So as long as I'm there, can I just go back and find the cosecant right away? I can. Cosecant would be square root of 29 over 2 negative in there somewhere. Doesn't matter. So that one, I'm just going to reciprocate it right away. All right. Cosine 5 over square root of 29. Do you see the pattern yet that this is just going to be 5 square root of 29 over 29? Okay, unless it simplifies, like that's the pattern every time. It's super nice. Should it have been, and it's positive because the hypotenuse will always be positive. And then the x-axis was positive 2, so it's positive. All right, then this is upside down, square root of 29 over 5. Okay, tangent. Negative 2, opposite over adjacent, so negative 2/5. And then this is negative 5/2. Ah! All right, those just take some thought, so make sure that you're drawing the question. This is one of the things that people forget the most, but it's important just conceptually that you can put that together.